Hi there. Let me take a few minutes and hit some of the highlights regarding residuals and residual plots. Number one, you need to know how to calculate a residual. It is defined as the actual response value, the actual Y value observed in the data. Take away the predicted or the estimated response value. This is all a residual is. It is the difference between the actual and the predicted value. So essentially, the residuals are what are used to create the estimated slope and the estimated y-intercept. For those of you that are interested here, really what goes on when you create a linear regression, it's really known as least squares linear regression. And the reason it's least squares, those residuals, some of them are positive, some of them are negative. So every residual is calculated and squared. So that way you can add them without them canceling up. And the idea is that the estimated slope and the estimated y-intercept are exactly those which make the sum of all of the squared residuals as small as possible. So we are trying, if you will, to find the slope and the y-intercept that minimize the square of all of these errors. The most important thing, though, is you at least know the basic definition, actual minus predicted. And that's what questions 1, 2, 3, and 4 are about on the front of the study guide. So here is the same model that we've been using for all of our examples. Predicted exam score for the girls in my pre-calculus class a few years ago. Negative 1.69 for the intercept. The slope is 0.96 times their homework average. So understand the very first value in the data set, the first ordered pair is 7876. This is actually on the scatter plot. So there was a girl who had a 78% homework average. She earned exactly a 76 on her exam. Now that is the 76, the actual response value, the actual Y value. Our linear model predicts a slightly different score for her. Here is where we would calculate her predicted score, the intercept plus the slope times her actual homework average. Her predicted score comes out to be 73.2. So there is a residual associated to this individual observation. The actual exam score for this young lady was 76. Her predicted exam score was 73.2. The difference is the residual. The difference is 2.8. So an important observation to make, this residual has a positive value. 2.8 is positive. But what that means, the linear model in this case is under predicting the value of the response variable. A positive residual suggests under prediction. It indicates under prediction. So look, the predicted value is 73.2. That is certainly underneath her actual exam score of 76. A positive residual indicates under prediction. So you can guess what questions 3 and 4 are about. You probably have a situation where you have a negative residual, so you get to write about that in step 4. So continuing then, the residuals represent the error that the model is making. So we hope that these errors are not predictable, that these errors are not consistent. If the model is a good fit, we would hope that the residuals are pretty random. So in order to evaluate this, we calculate what's called a residual plot, and most of it you can do automatically on your calculator. So you need to make sure that the last regression that you have run is for the PC homework data for the girls. So I've already made sure that the PC homework girls data list is in list 1, PC exam for girls data list is in list 2. I am going to go ahead and rerun the linear regression because the last regression that you run on the calculator, I am going to rerun that regression. Whatever the last regression is that was run on the calculator, the residuals are automatically stored on a list in the calculator, and it's easy to plot them. So here on your study guide, I gave you a screenshot of what your plot 1 should look like. It should be on, set to a scatter plot, using the actual explanatory data and then the residual data that was saved into the Y list. So we need to get it there. So I'll show you how to do that here. The directions are on the study guide, but I'll step you through it. So my plot is on, scatter plot is set, the X value is set to the explanatory data in list 1. Highlight list 2. If you press second stat, you can go to the lists, and I'm going to press the up arrow to go down to the bottom. alphabetically, resid is automatically saved onto your calculator. These are the residuals from the last regression that was run. I am going to specify that in plot 1, and then I can zoom 9 it. So we are literally looking at a plot of the errors that this model makes. So these positive residuals here suggest the moments where we under-predicted exam scores. These negative residuals here suggest where exam scores were over-predicted, but there is no pattern there. That scatter plot is reasonably random, and that suggests that the linear model is a good fit. If I were able to see a pattern in this scatter plot, that would suggest that the model is consistently making an error over time, and the linear model isn't able to account for that error. A residual plot that suggests the linear model is a good fit is a plot that is reasonably random, a plot that is reasonably scattered. I don't want to see a pattern here. And that's what the rest of the study guide is about. On question 6, you are specifically being asked to reload the speed and fuel data. This is not a linear pattern. We already know that this was a curved pattern. I'm telling you to run the linear regression. I'm telling you to hit zoom 9 then to see the residual plot. This is an example of a residual plot where you will see a pattern to the errors, and filling in this paragraph, you are looking at what those errors mean and interpreting that pattern. The linear model is certainly not a good fit for the speed and fuel relationship that we've looked at before. And then finally, questions 7, 8, and 9, you are looking at pictures in the textbook to decide when is my scatter plot, my residual plot, reasonably random and scattered enough to believe that the linear model is a good fit. It should be relatively clear. Something to think about, here are the 4 homework questions. So for question 3.41, I'm specifically telling you to enter the data and save the data into 2 lists. Here are the names of the lists that I suggest. And notice that I told you to skip certain parts. That is perfectly okay. I'm trying to focus you on specific parts of the questions that I think are important as of this point in our class. Hope this has been helpful.